Let's start with our next topic. So this topic is tool selection. That means how to select tool that we use. So in this topic, we're going to see insert selection, external tool holder selection, internal tool holder selection, and insert failures and its remedies. That means we will see how to select insert external tool holder, internal tool holder, and also we will see insert failures and its reasons, and how can we avoid insert failures. So let's start. So first is insert selection. Here I have taken TNMG insert for an example so that I can teach you this insert selection with the help of this example. So here we have TNMG 140408. These are total 7 parameters, and each parameter have its meaning. So let's learn this in detail. So first is shape of insert. That means here, shape of insert is taken as first parameter. Second is insert clearance angle. Third is tolerance grade. Fourth is chip breaker and clamping. Fifth is size of insert. Sixth is thickness. And seventh is nose radius. So these are total 7 parameters. So let's learn them one by one. So our first parameter is shape of insert. We have regular shapes and irregular shapes. So what is shape of insert? It's regular or irregular. Regular shapes mean standard shapes like triangular, rectangular, squares, and irregular shapes means shapes that we get after some modification in regular shapes. Here, T means triangular shape, means shape of that insert is triangular. R means round, L means rectangle, P means pentagon, H means hexagon, and S means square. So these are the letters for that shape. And from that, we get to know the shape of insert. And in irregular shapes, we have C. If we modify square insert by giving 80 degrees to its 2 corners, then that insert is C-shape insert. What's in D? So if we give 55-degree angle to that 2 corners, then that shape is denoted as D. In V, we have that 2 corners of 35 degree. If you've seen VNMG insert, which is much longer, so 2 corners of that insert are of 35 degrees, and in W, hexagon shape insert with 3 corners of 80 degrees. That means it's a modification of hexagon. So from our first parameter, that means from these alphabets, we get no shape of insert just by looking at these alphabets. So our example was TNMG insert. So T means triangular shape. That means insert will have triangular shape. Second parameter is insert clearance angle. So if we draw a straight line from the tip of the insert, and if we measure that angle from the straight line to the face of that insert, then that angle is the relief angle, meaning the insert clearance angle. Here, a smaller angle will have larger surface contact, and larger surface contact will help to remove more material, as large surface contact will create large pressure. As you can see, N has a 0-degree clearance angle. Due to this 0-degree clearance angle, this insert is able to have total surface contact with the material. Because of this, large pressure gets applied, and this helps to remove more material. If we see G, it has a 30-degree clearance angle. In this case, only a smaller portion of the insert will come into contact with the material, and due to this, it will not be able to apply more pressure. That's why it will not be able to remove more material. Thus, the N symbol insert, which means a 0-degree clearance angle insert, is used or preferred for the roughing process. As you know, in roughing, we have to remove more material. Hence, the 0-degree insert is preferred. For finishing, some clearance angle insert is preferred. Due to this clearance angle, we get a better surface finish. So for roughing, we use N-stent, that is a 0-degree clearance angle insert, and for finishing, we prefer some clearance angle. But remember, more clearance angle will remove less material. So use this clearance angle insert according to your surface finish requirement. So this is all about insert clearance angle. Our next parameter is tolerance grade. As you can see, we do not get exact size. After machining for all the jobs, we will get some plus or minus size than required. So how much plus or minus is allowed for that job is known as tolerance. So as you can see in diagram for diameter 1, we have plus minus 0.03 tolerance. That means 1.03 is also allowed and 0.97 is also allowed. That means any diameter from 0.97 to 1.03 is accepted here. So 1.03 is called higher limit and 0.97 is called lower limit. So this tolerance is for this diagram. So I will repeat once again. So when we do machining for any job, some plus size or minus size is given to that job, as we do not get exact size all the time. And that's why some plus size or minus size is provided for the job. So that plus size or minus size is called tolerance. Here we will learn one small concept. So as you can see, 1 meter is equal to 1000 mm, and 1 mm is equal to 1000 microns. So these two are the conversions that you have to remember. So coming to the topic, tolerance grades. So we have two grades, M grade and U grade. In M grade, we have plus minus 0.05. That means plus 50 micron is allowed and minus 50 micron is allowed. And this is mostly preferred for turning. And U grade have plus minus 0.08. That means plus 80 micron is allowed and minus 80 micron is also allowed here. And this U grade is mostly preferred in milling. So we have these two tolerance grades.